Electrical machinery 1. Problem. 7 marks and 2 marks. Topic. Compound mode generator or compound generator. DC generator. Compound generator. Electrical machinery 1. Problem. Long shunt compound generator delivers a load current of 50 amperes and 500 volts. The armature resistance is 0.05 ohms. The series field winding resistance is 0.06 ohms. And the shunt field winding resistance is 250 ohms. Calculate the generated EMF and the armature current. Allow 1 volt for per brush, 1 volt per brush for contact drop. Solution. Given values in above questions are IL is 50 amperes, VL 500 volts, RA is 0.05 ohms, RSC is 0.06 ohms, brush is 1 volt per brush, RSH is equal to 250 ohms. Calculate generator EMF and armature current. Circuit shown in figure, that is IA, IS, and IL directions are given. Rheostatic winding is given, load is given. Formula EG is equal to VL plus IA into RSC plus RA plus 2, where 2 is 1 volt per brush is equal to 1 plus 1 is equal to 2. That is for 2 brushes. IA is equal to IL plus IS hash. IS hash is equal to V divided by R. EG is equal to VL plus IA into RSC plus RA plus 2. ISH is equal to V divided by R is equal to 500 divided by 250. IA is equal to IL plus ISH is equal to 50 plus 500 plus 250 is equal to 52 amperes. EG is equal to VL plus IA into RSC plus RA plus 2. 500 plus 50 plus 500 divided by 250 bracket into bracket of 0.06 plus 0.05 bracket plus 2. 2 is volt per brush. EG values we obtained. I0 7.72 volt. Armature reaction is neglected. Armature current IA is IN plus IH is equal to 52 amperes. EG is 507.72 volt. That is answer. DC generator. Second problem. Compound generator. Electrical machinery 1. The compound generator has armature resistance is RA. Shunt field winding resistance RSS or SH. Series field winding resistance RA is 0.06, 25 and 0.04 ohm respectively. The load consists of 200 lamps each rated 55 watts and 110 volts. Calculate the electromotive force and armature current. This machine is connected. A. Long shunt and B. Short shunt. Ignore armature reaction and brush drop. Above questions given values are RA is equal to 0.06 ohm, RSH is equal to 25 ohm, RSC is equal to 0.04 ohm, PL is 110 volt, lamps is equal to 200 lamps, power is equal to 55 watts. Calculate force and armature current. Circuit shown in figure. ISH and IA and IL directions are given. Load 200 lamps, 25 ohm. RSH is 0.06 is RA, RSC is 0.04. ISH and IL directions are given in circuit, long shunt circuit. Formula W is equal to VI, W is VI, V is equal to 55, I is equal to 110. Each lamp consumes currents I is equal to 55 divided by 110. From this, I is equal to 0.5 ampere. Total lamp consumes current I is equal to 200 into 0.5. Total lamps into I 100 ampere. IL is equal to 100 ampere. That is answer. ISH is equal to VL divided by RSH. VL is equal to 110 volt. RSH is equal to 25. Put required values in ISH formula 110 divided by 25. We obtain ISH is equal to 4.4 ampere. IA is equal to IL plus ISH. 100 plus 4.4. 104.4 ampere. IA value is 104.4 ampere. EG formula is short. EG formula is VL plus IA into RSC plus RA. 110 plus 104.4 into 0.04 plus 0.06. EG is 120.44 volts. Short shunt circuit is shown in figure. Shunt field winding is connected between the series winding and armature of generator. IL is equal to ISC is equal to ISC is equal to IA minus ISH. VL is equal to 110 volts. IL is equal to 100 amperes. Voltage drop of series field winding IL into RSC is equal to 100 into 0.04. VSC is equal to 4 volts. VA is equal to VL plus VSC is equal to 114 volt. ISH is equal to VA divided by RSH is equal to 4.56 ampere. IA is equal to IL plus ISH. IA is equal to 104.56 ampere. EG is equal to VA plus IA RE. 114 plus bracket of 104.56 into 0.06. EG value is we operate 120.2736 volts. Voltage regulation of a DC generator. The circuit diagram is shown in figure. Generator is connected to rheostatic resistance and shunt field winding, and load is connected parallel. Shunt winding is connected parallel. That is voltage regulation circuit. Voltage regulation of a DC generator at a given load is defined as percentage change in the terminal voltage when the load is disconnected, keeping the RPM and the field current constant. Good regulation, change in voltage between no and full load small. Poor regulation, change in voltage is large. The voltage regulation of a DC generator is the change in the voltage when the load is reduced from rated value to 0, expressed as percentage of the rated load voltage. Percentage of regulation is VNL minus VL divided by VL. VNL is equal to no load voltage. VL is equal to load voltage. Example, DC generator no load voltage is 240 volt. Rated load voltage 220 volt. Percentage of regulation is VNL minus VL divided by VL is equal to 240 minus 220 divided by 220 is equal to 20 divided by 220 is equal. Percentage of regulation is equal to 9.1%.